I thought what I could do is go over quickly the presentation that we gave at Borderless Cyber last month on the 12th. And the reason that I think this is appropriate, it really does give a relationship understanding between the Threat Actor Context Technical Committee and the STICS, the CTI TC. So all members of the TC really contributed to this, but we called out Tim Casey in particular, since the theme of that Borderless Cyber was privacy as well as cybersecurity. And the use case that we built on really extended the Intel Corporation's application of threat actors, and we extended that to deal with the use case of a curious healthcare worker. But obviously, the C-suite is most interested in staying out of the headlines. So as we've been developing the threat actor context ontology, a little bit about how this has evolved, but really what we're finding out is it's giving context around threat actors, not so much for those that are groups that we might want to lay attribution to, but the ontology, the threat actor context ontology, really gives us a platform to actually create the threat scenarios or create the threat actors that we are most fearful of as a corporation. But obviously, one of the main benefits of using the TAC TC is, from the perspective of the C-suite, is staying out of the headlines. So quickly, what we presented, and we only had 20 minutes to present at this, but we tried to present the problem that's being faced, the solution, what it means to the listeners of that group, why use the TAC TC and the threat agent library from the Intel Corporation. We wanted to clearly make sure that everything we were doing in the TAC TC was built upon STICS 2.1, but we wanted to extend the STICS 2.1 JSON and represent that in a form that a true full semantic graph as opposed to the property graph. But the benefits of the threat actor context ontology is really, for years, I've been inspired by the Sun Tzu story, analogy, quote, if however you want to put it. But you got to know thine enemy. You have to know more about the threat actor, and that's what the focus of, obviously, the threat actor context ontology is all about. But it gives us a language to describe fully the adversary types that we're most interested in protecting ourselves from. I mean, we know the facilities and the enterprise and the architecture that we're trying to protect, and this gives us a language to describe the adversary that's most relevant to us. It helps us understand the association of the TTPs that those threat actors have available to them. But most importantly, the threat actor context ontology allows us to capture what we know about ourselves, know thyself. And it gives us a means to institutionalize and the corporate knowledge that we have, that our security analysts have tradecraft, and it allows us to capture that tradecraft, their logic and knowledge within this expressive ontology. So it helps us to fight against that brain drain. When your cyber analysts, when your security specialists leave the company, with this language, we can retain that, and it allows us to have a machine readable copy of that knowledge that those cybersecurity analysts brought to the company in the first place, and allows us to retain it so it doesn't leave when our analysts leave. First and foremost, we wanted to give an understanding to the listeners at that conference what our roots were. And obviously the roots of the threat actor context ontology was our group, the CTI TC. So that sticks language is the basis, the foundation upon which the TAC TC is built. So our framework wanted to take the STIX language and make it semantically interoperable with many of the systems that were out there. So the goal was to enhance the strategic, tactical, and operational intelligence products and this is all within our charter. We'll see, but foundationally, our roots. And I guess the best way to give it, since I'm showing you a stack here, is the foundation upon everything that was built is the STIX 2.1 specification. What we did, the first activity that we did, was to put into an ontology, so formal ontological language, that specification. So as tightly as we could, we took the specification and represented it in OWL, the web ontology language. So the lower two blocks in this foundation, that's really important. So the STIX 2.1 ontology, stix.owl, this is the tightest representation we could make of the specification without really extending the specification. From there, we went on to build what, I hate to overload the term, but an extension to the STIX language and added the classification of different types of threat actors. And we based this, as did the specification, on some of the earlier work of Intel Corporation to define what a threat actor was with the threat agent library. And then on top of that, we extended even further to cover healthcare worker. I'm going to check my time here because I get long-winded, and if I don't pay attention to time, I could run us over here. So with some of you have probably seen this from years ago when it was presented, but the threat agent library at Intel started to break down, well, what are the different classifications that we can put threat actors into? And they created a matrix. Given the defining characteristics that we'll call out with respect to their motivations, the outcomes, the limits they have, the resources they have access, the objectives that they have, given those as defining characteristics, what do these different threat actor types, these classification types, what defining characteristic do they have? So they created a matrix such as this that you're looking at. So what our intent was with the ontology was to capture the knowledge of these classes of threat actors as axioms within our ontology. So what we did was take, and we have code that is in our GitHub repository that allows us to take the STIX 2.1 JSON and convert it into an RDF graph. And that allows us to use graph analytics tools to actually understand what might be in a report, the ability to visualize in a graph form. This happens to be a visualization from Stardog. But you're able to look at the facts that are within that graph, which are really the assertions that are in the STIX 2.1 JSON, and to actually make inferences based off of the knowledge that has been embedded as well. I don't have a clock visible to me. Where am I at in time? Do I have a few more minutes or?
Yeah, you got 20 minutes. Like, yeah, it's 41. So you got like 19, 15 minutes.
Okay, great. So super. Um, so we wanted to be able to do this classification automatically. This is semantic graphs were kind of the first wave of AI. So we wanted to do this in not only a human readable form, but a machine readable form, and to be able to have that ability for AI, basically, to be able to make inferences based off of the facts that were asserted, based off of the facts that we know. What formal logical conclusions can we draw to add new facts? So the first thing that you'll see with the TAC ontology is that we've added more or less the hierarchy that is implied by the STIX specification. So you'll see some STIX objects that are defined, which are broken down into the basic different types that are specified in the STIX 2.1 specification, the STIX domain objects, the cyber observable objects, the metadata objects. So we've created an abstraction of this hierarchy. And you can see from this slide that the STIX domain object obviously includes the STIX threat actor object, and we've been able to extend that to the TAL. If you see that it's an eye chart for you, I understand that. But this is the STIX threat actor, and subclassed under the STIX threat actor are the threat agent library definitions of the different classifications of threat actors. So anarchist, civil activist, competitor, data miners, internal spies, government spies. So all of the defining characteristics that we saw in that matrix from before are the defining characteristics that specialize what a STIX threat actor is. So in this case, you're seeing the hierarchy that, there's a STIX object, a STIX domain object, which is one of them is the threat actor. A subclass of the threat actor would be a reckless employee. And we've even extended that with a healthcare agent library that includes the definition of what a curious healthcare worker is all about. So again, once we specify, and we can do this in the STIX 2.1 language, feed that report or that study into through the code that we have to elevate it into a graph, and then we can analyze that graph in many of the platforms that are out there for graph analytics, Stardog, GraphDB, Allegro Graph, many of these other tools. So it isn't vaporware. We actually have code. Earlier, we tried using, and with success, we tried using defining contexts for the JSON. Because as everybody knows here, that STIX 2.1 JSON is not JSON LD, it is JSON. And so what we wanted to do is to be able to get that JSON into essentially a JSON LD form. And so we thought we would use descriptive context to help us make that conversion. But we found a different technology that's standards-based as well. And it's a standards-based extension of the Sparkle language. So via a technology called Sparkle Anything, open source, standards-based, we were able to much more rapidly and accurately translate the JSON 2.1 documents into RDF format. This code is also on the GitHub repository. This was a significant step forward that happened earlier in 2023 for us. So here's the, I like this one. I don't know how many of you on this call remember the Ronco commercials, but here's the Ronco cordless electric. So it allowed us to take our threat actor descriptions, and of course there's threat actor descriptions of the different APT groups and that are there that have been represented. But what we've found is that through this language, it's an expressive language that we can actually describe the threat agents and the threat actors that are most concerning to the enterprise. But we can do it now in a human readable form, and it's machine readable, and we're able to automate this kind of classification based off of an understanding, a succinct definition of what the defining characteristics are of those classes of threat actors. We're able to use this language to capture the analyst tradecraft. In other words, hospitals and the security analysts at hospitals do have an understanding of what a curious healthcare worker was. Remember, the theme of this conference was indeed concerning cybersecurity and privacy. And so we could actually, and did actually, create a description of what a curious healthcare worker was in the terms of the specific enterprise that was trying to describe the threat that they are posed, that's posed to them with their staff. So we now have a semantic graph version of what's in a STIX 2.1 representation. And there is the GitHub repository that you can look at. And then we offered demonstrations on how the TAC Ontology in DAC, we offered demonstrations so that they could see how it worked. Some of the things I would like to make sure that you're aware of, if I can figure out how to show it here. There is our repository. We've been working through the issues. Everything's on a volunteer basis, and of course, I'd love for anybody interested to consider joining the group that we've got, and we've got some priorities. One of the things that's been on our list for a long time, Jeff Mates and others have been helping us, is we want to, and the review that's going off on the extension mechanism is really relevant to the TAC TC, because keeping the TAC ontology and the extensions that are being considered and reviewed and added to STIX, this mechanism, we really need to make sure that we're in sync with the extensions that get added to STIX so that they can be reflected in the TAC TC. I see this as one of the higher priorities of what the TAC technical committee has to do. And then a lot of the others here are just a matter of, I won't say cleanup, but improvement upon the representation that's in the ontology. So with that, I can really open it up to questions if anybody has any. I can, also, I guess I could show you some of the things. Here's the bottom line. Here is the TAC ontology represented, and for demonstration or for visualization purposes, one of the definitions of a threat actor is certainly, you can see that there's a number of types of threat actors that can be classified as subclasses of a threat actor. And of course, a threat actor is a STIX domain object, which is a STIX object, which is an OWL thing. But if we were to look at one of those individuals that I've put in here is a person of interest, and I've associated that person of interest with certain characteristics that are based off of observables, the STIX observables. What do I know about this person of interest? And if then I actually start the formal reasoning process, those determining factors are considered, and an inference is made with the inference engine that indicates that this STIX threat actor is actually a curious healthcare worker. So that's kind of the bottom line of what we're trying to do here. Human readable, machine readable, and automatable. So with that, that's what we presented at Borderless Cyber last month, and kind of a overall high-level view for you. If I've got any questions, happy to take them.
Hi, Ryan. I have a question. I know you mentioned the importance of the STIX extension work that's going on right now within the CTI TC, and how that will have an impact for the way that you move forward with the extensions within TAC to make sure they're in lockstep.
Yep.
Have you started taking those extensions and putting them into the aligning them to the STIX extension policy document? We're revving it up, but I just wanted to know, have you already on that path?
I would like to say absolutely yes, but I can't. I've reviewed that path. I reviewed the documents that are there, but we just haven't had the bandwidth to put towards aligning them as much as I would like to. I think if you review it, this was the third issue that we opened back in October, and we're getting really close to having opened this particular issue 2 years ago. So as time has gone on and as our capabilities have improved and we've started to actually gain some momentum, I'm realizing how important this is, and we're going to have to put some energy and effort into it.
Okay, and as you mentioned, and as Emily's and Rich talked about earlier, we are in the process of making those changes. So definitely look to see any participation and feedback into that process, so that you'll be able to see how those things go, and any lessons learned, suggestions from the TAC TC into that process, for those that can participate within the CTI TC. So I think that'll be great.
Yeah.
And then I have one more question. This is more on the visionary aspect. So we talked about through your presentation how this, having it in a knowledge graph will allow folks to not only have inference, which is one of the most powerful things you can do with knowledge graph, and its intent purpose, and then to be able to share that. Is this something that you see, or how do you see this also being applied in different cybersecurity tools by different analysts or teams or SOCs?
Okay, so really, that is a great question. So up to this point, we have been taking the graphs that we built out of STIX documents. So we take a STIX document, will up. I'm avoiding the word elevator because of its. I don't want to overload it from that which takes us from 2.0 to 2.1 or 2.1 to 2 2.2. But we have code that translates the sticks JSON into RDF. And we've been doing our analysis in off-the-shelf software such as GraphDB, AllegroGraph, Stardog. But where I see this going is that this needs to be integrated with the tools that are in use now in our community, because nobody's in that community is going to want to work directly with a graph platform. They want to work with tools that are tailored towards the cybersecurity tasks that they've got at hand. And to that end, we've kind of dedicated, I've made a personal commitment that I want to be ready and prepared for March 2024 with the next Plugfest to incorporate the TAC TC into some tools that are being used. And of course, for some time now, we've seen the adoption of open source tools, whether we see it from the Hive or we see it from Open CTI. So I think that's where TAC TC needs to go, is an integration with these open source tools so that they can actually see the value of what's happening within the TAC. One of the challenges, sorry, you asked a question that I've been thinking a lot about, sorry. One of the issues that is important, and I think I've got it on the our list of issues, is that we can certainly elevate from the JSON 2.1 representation into an RDF version. But the conversion back to share the inferences is going to be a challenge. And that's why that extension mechanism is so important, because ultimately I would like to see these, with the TAC Ontology literally has made extensions to what is represented in the sticks language. But we don't have a way to pass those inferences and those extensions back down unless we fully understand the extension mechanism. So we can certainly port and make use of the TAC TC in these other tools, but we want to be able to go round trip. I want to be able to take the results of this analytics and pass it back down into a sticks representation so that it can be shared again. Does that make sense? I don't know if that answers your question.
No, it does, and it provides a lot of space for collaboration between the various efforts and things we could work on together in that approach. Because I could definitely think of some possibilities. Need to get more informed on the tax side of it, but I definitely think some possibilities of ways to achieve that. But like you said, I think that extension mechanism is going to be a key, and then there may be some other things we may be able to do that are more native as well. So I definitely think there's some path forward on that.
Well, thank you guys for letting me share all of this. I appreciate it. I'm going to stop sharing now if I can figure out how to do that.
Thanks, Ryan, and I think that ends it. We are right on the top of the hour for our monthly CTI. We're on top of the hour for our CDC portion. So thanks everybody for joining. Talk to you all later. Thanks, Ryan. Again, Ryan. And thanks, David.